Okay, I'm just going to kind of refresh because I just got a phone call and had to stop my video. So I guess this is part 3. In the last video, we were just doing this problem. We just finished up standardizing our 21 turning into 1.25, and we're going to the table. So you'll notice the table we used before, all of these values are negative. So we flip it over, and we can see all the values are positive. And not only that, positive z's mean we're shading more than half of our table. Our z is on the right of the mean. So we're going to look up 1.25. Here's 1.2. Here's 5. We go over, and we get our number. Please note that you can use a sheet of paper to kind of help you find that straight line if it's easier, whatever you need to do to make this table work. So 0.8944 was what we got from our table, and it is everything to the left of 1.25. And you'll notice in this case, that's actually what we wanted. We didn't need to subtract off anything because we didn't have a middle chunk. There wasn't a little tail we didn't want at the end. Now please note, if I wanted the greater than 21 side and not the less than, because this adds up to 1, whatever 1 minus this side is, that'd be the other side. So that's another trick you can use, is subtract from 1 if you want the other side. There's lots of little tricks you can pick up. I'm not going to go over all of them. So that's our answer. As percent, it's 89.44%. So now let's do that same thing on our calculator. Again, we use normal CDF. Our low, oh well, that one's tricky. We don't really have a lowest value. It goes on forever down. And your book's going to give you some way to write that, but it really doesn't matter. What I just write is negative because it's going on forever on the negative side. 9999999. However many nines, it doesn't matter. What matters is that it is much lower than all the other numbers you're doing. Our highest number was 21, our mean was 16, and our standard deviation was 4. Please note I am not using the standardized 1.25. You do not have to standardize your data if you're doing it on your calculator. You literally just put in the numbers you were given. Now, some people argue that fish could not be negative 9999 inches long. And you know what? You're right. Some people will put 0 here, but it really, really doesn't matter as long as your numbers are far away from the other numbers. You're going to get basically the same answer, so put in 0 if it makes you happy. It really, really, really doesn't matter. Technically, normal's going forever. So I'm going to go to my calculator. There it is. And I'm going to once again go turn it on. Second dister. Number 2 is normal CDF. And then I'm going to put in my same 4 numbers. Negative, really quick note, that button right there is a subtraction button. That is not negative. This little button down here is negative. Your calculator knows the difference and will not be gentle if you do them wrong. So, negative 99999, comma 21, comma 16, comma 4. Lower bound, upper bound, mean, standard deviation. And we get about 89.44% if we round to 4 decimal places, 0.8944. And we see that once again, it exactly matches what we did by hand. So that's how you do this direction. I give you cutoffs, I ask you for percents. You either use the normal CDF, lower, upper, mean, standard deviation, or you do it by hand, standardizing, and then using your table and figuring out how your areas match what you want. So there's another way we can go with this, and I'm going to ask you 2 more questions. How long are the shortest 20% of fish? So again, I want to start with a picture to note the difference between this and the previous question. It's still normal. My mean is still 16. But now instead of saying what percent are in this length, I'm asking how long goes with this percent. It's going backwards. And notice short fish are over here. So I'm just going to shade some of this spot. I don't know what the cutoff is. That's kind of what I'm looking for. But I know this area is 20%, or as a decimal, 0.2. So we can do this again, either by hand or by calculator. I'm going to do calculator first this time. The other questions I did hand first. Let's just do calculator first. But again, I'm going to do it down here. Because this is going backwards, I gave you the percent and I want the cutoff. We're going to use not normal CDF, but inv norm, inverse normal. Inverse means go backwards. And if we remember from the first video, our inverse normal takes the area to the left of our cutoff, mean, and standard deviation. And so, looking at our picture, the area to the left of our cutoff is 20%, but we need to write it in decimal form for our calculator, 0.2. Mu is still 16, sigma is still 4. So we're just going to put inv norm, 0.2, comma 16, comma 4, into our calculator. And inv norm is again where second distributions are. And inv norm, you can see, is number 3. And I put in my left area, my mean, and my standard deviation. Inv norm, 0.2, comma 16, comma 4. And the answer is about 12.6. Now, what does that mean? That means this number right here is 12.6. Now, let's be really, really careful. How long are the shortest 20% of fish? Well, all of these were the short ones. So our fish are either 12.6 inches long or shorter. So we would say our answer is 12.6 inches long or shorter. It should be a range of values, not a single value. All the shortest 20% of fish are not exactly 12.6 inches long. They're 12.6 inches long or shorter. So we want to say that in our answer. So that's how to do it on the calculator. Now let's do it by hand. We're going to do the exact same method we did before, just backwards. We're going to start using the table. And this is a little different. So let's go through this slowly. Notice the area we want is less than half the graph. So this is the wrong side to look at. We're going to look over here where the area we're finding is a small area. And remember, the answer we got was always in this part, what we call the body of the table, not the edges. And so I'm going to look for the answer 0.2. And I will probably not find it, so I'm going to look for the closest I can get. And you'll notice it starts with teeny tiny numbers. Be careful, don't look for 0.02 or 0.002, look for 0.2. The numbers get bigger as they go down and as they go sideways, so you're like too small, ooh, 0.2005, that's pretty close. 0.19, oh, that's smaller. Oh, 0.2 would literally be somewhere in the middle if we had it. So what we're going to do is we're going to pick one. Which one was closest to 0.02 to 0.2? 0.2005 is only off by a 5 in the 4th decimal place. It's off by 0.0005. Whereas this one is off even in the 3rd decimal place. So it's off by, say, more than this one. So we're going to use this number and we're going to go backwards. We're going to find out what row it's in and what column it's in. The row it's in is the row just above the one I've already drawn, or negative 0.8. The column was 0.04, so negative 0.84. And so we're going to write our z was negative 0.84. Now that we have our z, we can unstandardize it. Remember our standardizing formula was this. So we're going to put in negative 0.84 equals the x I don't know. Let's get this out of the way. Minus my mean of 16 divided by my standard deviation of 4. Now we can do that, or we can just solve that formula for x, and if you solve that formula for x, you would get this new formula. So that's a formula that's good to know too, but let's actually do it by hand. We multiply the 4 to the other side, and I'm going to cheat and use my calculator. I would, on a test, if I really wanted you to not have a calculator, I wouldn't give you numbers that were this messy. Negative 3.36 equals x minus 16. Add the 16 over, and we get x equals 12.64, which, hey, matches the 12.6 we got from the calculator. Now again, it wasn't technically 12.6 on the calculator, it was 12.6335. So this would round to 12.63 on the calculator, but 12.64 on by hand. Not really a big difference, and as long as you're showing your work, I know what you're doing, life goes well. So that's how you do it on the calculator and by hand. Let's do the same kind of problem one more time. We're looking for now the longest 15% of fish. So again, I start with a picture. The mean is 16. Long fish have big lengths. I don't know where the cutoff is, but I know my big area, my upper area is 15% or 0.15. So doing this on our calculator, we do inv norm because we're going backwards. I gave you the percent, I'm looking for the cutoff. Now remember, this number is always your left area. That doesn't say 6 feet, that says left. Well, if the total area is 1, and this side is 0.15, we can subtract and get that the left area has to be 0.85, and that's what we're going to give to our calculator. So we don't always give it the percent we were given. We have to find the left. And our mean is still 16, and our standard deviation is still 4. So I'm going to go to my calculator. I'm going to find, there it is, again, second distributions. Inv norm is number 3. My left area was 0.85, comma, my mean was 16, comma, my standard deviation was 4, close my parentheses. And I get 20.1 about. We will describe what this means after we do it by hand once as well. By hand, we are going to, first of all, use our table to turn a left area of 0.85 into a z. And since your calculator also does just left areas, we still want to do that minus from 1 to get 0.85 thing. And as that left area is a big area, we're going to use the positive side. 0.5, 0.7, 8.2, 8, oh, look, here's 8.5, 8.4, which is closer. This is again off by only the third decimal place. This is off by 2 more decimal places. You can also just subtract. 0.8508 minus 0.85 is 0.0008. 0.85 minus 0.8485 is 0.0015. So this one's closer. We're going to go backwards and see this is at 1 and 4. So 1.04 is our z. And we're going to unstandardize. If we don't want to do all the work by hand, there was the unstandardizing formula. Our x is our mean, 16, plus our standard deviation, 4, times our z, 1.04. And again, if you were really truly going to do this without a calculator, I'd make the numbers slightly nicer. But we get 20.2 if we round it to the nearest 1 decimal place. But either way, our final answer is the the longest 15% of fish are 20.1 or 20.2, whichever one we want to use, that's fine. And longer or inches, don't forget your units. And longer or longer, I don't care if it's and or, what I care is you say 20.1 inches, maybe 20.2 inches, and then you include, but there's more, and longer or longer, that is our final answer. So that's how to find these normal questioned answers by either using your calculator or by using the table. And again, I want you to be able to use either method. I might on a quiz or a test say use the table, or I might say use the calculator version and give you problems you could do without a calculator either way. Okay, so I hope that's helpful. That's the end of chapter 3. Have a good day. If you have any questions, let me know.